Okay, so now we'll go with the interface commands. Okay, so now let me just tell you. So let me take Paint, okay, and just tell you about this one. See here, the router has got the ports, and you know the function of the ports. The previous day I told you the function of the ports, and we connected the router using ports. Now you will have, in addition to the ports, you will have some more thing called interfaces in the router. So now let me just show it to you here. If you take the router in the packet tracer, so here when you take it, and when you take this physical, okay, so let me just again zoom in. If you can see, this is the ports here. Okay, so this is the console, this is the console port, and this is again say another port or the auxiliary port and all. Okay, so you can see the console port here and the auxiliary port, and these are the interfaces. If you look onto this, these are the interfaces. Now you got some empty slots as well. There's some empty slots. This also another empty slot. This also another empty slot. Okay, if you are not using, say, you can just cover it. Okay, so let me just show it to you. We'll turn it off, and this is the cover. You can just use some covers here. Okay, so the same thing if you are using it. So now let me just tell you here, you can insert some interfaces by just dragging and dropping here. Where is it? Say you can add these interfaces here like this. Okay, so then you can turn it on. Okay, now let me just minimize. Okay, now let me tell you about the interfaces here. So I've drawn an interface. I mean, this is a router, and you will have many interfaces. Suppose this is an empty slot. Okay, so you can fill or you can insert some slots here. So suppose this is slot number 0, slot 0, and this is slot 1, the slot 0 and slot 1, and in the slots itself you can have multiple ports inside the slot. These are port number 0, port number 1, port 2 and port 3. So now let me tell you how you can name it. Okay, so naming will be done like this. First you will mention which interface it is, whether it is serial, whether it is fast Ethernet, whether it is, did I give you a list of the interfaces? Yes, I suppose, right? So I might have given you the list in the previous class, right? Serial interfaces, fast Ethernet interfaces, gigabit Ethernet interface, like that. Okay, so we will mention the interface type. So the interface type, so let me just show it to you here. When I take the router, okay, when I take this privileged execution mode, you can execute one command, show IP interface brief. Show IP interface brief. When you take this command, you can see many interfaces. Gigabit Ethernet 0/0/0. Now gigabit Ethernet 0/0/1, gigabit Ethernet 0/0/2, serial 0/1/0, serial 0/1/1, etc. You can see many interfaces. These are the interfaces. Now let me just tell you about the interfaces here. The status and the protocol. This is protocol, the status and the protocol. So the status can be, say, where is it? Sorry. So the status here and the protocol. The status can be up and the protocol can be up. It's called up bar up state. It means the interface is working fine. I mean the interface is perfectly working. Perfectly working. Now the status can be up and the protocol can be down. Status can be up and the protocol can be down. This condition, it is layer 2 issue. You're having some protocol issues or some layer 2 issues. Now the status here, it can be down and the protocol can also be down. And in this state, this is layer 1 issue. You are having some issues with the cabling or something. Layer 1 issue. And the fourth one, the status can be administratively down and the protocol can be down. So this means administratively down. That means we, administrator, has made it down. We have made it down so that nobody else would say connect it to it and use it. Okay, we have made it admin down. Okay, or you can say we have purposefully made it down. Made it down. Okay, so these are the 4 cases of the interface. So now by default, when you take this, or when you take the commands, or when you execute it, by default everyone will be, all the interfaces, the unused interfaces will be administratively down state, admin down and down state, because you will make all the unused interfaces down. Okay, now so here this, you can see this command show IP interface brief is say very important. You can see the interface details and whether the interface is assigned with an IP address or not. So again, let me tell you, did I tell you how you can set an IP address to a computer?
Yes, sir.
To the computer? Yes, right. So nothing is there. Say we'll go to this is the ncpa.cpl. We'll take this command and where you will get the interfaces. You will click on to the required interface. You will double click on to the required interface. You will double click on to the IPv4 and you can give whichever IP you want. Okay, this is how you will give. Now actually you are not giving IP to the computer. You are actually giving the IP address to that network interface card or that adapter. Okay, so here again you can see a wireless adapter here. I'm actually assigning IP address to that interface of the computer. So wireless, or say suppose it can be wireless interface, or it can be wired interface, or it can be some virtual interface as well. Okay, these are some virtual interfaces and these are like created by some other softwares or something. Okay, so now again similarly here you can give the IP address not to the routers but to the router's interface. To the gigabit Ethernet 0/0/0 interface you can assign an IP address. To gigabit Ethernet 0/0/1 you can assign an IP address. So this command lets you view whether the IP address is assigned or not, and what IP address is assigned, and what is the status and protocol of the interface. Clear? Okay, now you got one more command, show interfaces. Show interfaces will let you show all the interface details descriptively. I mean the descriptive details it will show. Show interfaces. Okay, so if you execute this one, you can see gigabit Ethernet 0/0/0 administratively down, line protocol is down, which you have already seen it here. Sorry? Okay, now then you can see the hardware details, then the address, the MAC address of that interface, then certain values, MTU, bandwidth. Say I told you about the bandwidth. For gigabit Ethernet, say the bandwidth is 1 Gbps. When you calculate it, you will get it as 1 Gbps. Okay, now delay is 10 seconds. Okay, now reliability, you can see many values here. Descriptive details, that's why I told you you can view the descriptive details of the interface. Now when you press the space bar, you can see it page by page. You can see the gigabit Ethernet 0/0/1 details, many details you can view, and the next one gigabit Ethernet 0/0/2, and again serial 0/1/0, again serial 0/1. So you can see the descriptive details of all the interfaces here using this command. Now let me come to the naming one. I mean say the names here, gigabit Ethernet 0/0/0. So now let me just tell you about it. So here, where is it? Yeah, so here suppose I told you about slots and ports now. Okay, so now you can have modules as well. So the router, say for the larger routers, they have multiple modules. So suppose this is a module 1 or this is module 0. Now say again, if suppose these are again the same router, you can have module 2 or module 1, and inside the module 1 itself you can have multiple slots. and inside the multiple slots itself you can have multiple ports. So here you will name it like this. So suppose this is module 0, so this will be 0/0/0, and this will be here, it will be 0/0/1. So the first we will tell the module number, then the slot number, then the port number. So that's how it is named. So that's why you are having, or you are seeing this one. See here, where is it? So here you are seeing gigabit Ethernet 0/0/0. So first you will mention the type of the interface, whether it is gigabit or whether it is serial or whether it is fast Ethernet, like that you will mention. Then you will mention the, say, the module, then the slot, then the port. Clear? Now that if you want to configure this gigabit Ethernet 0/0, what you will do is that you will go to the config mode, configure terminal. You will go to the config mode and you will mention the command like this, interface. Then suppose I want to configure gigabit Ethernet 0/0/0. If I give this command, you can see I have moved into the interface. The prompt has now changed to config-if, which is the interface. But really you can't see which interface you have moved. For that you need to seek this help. I mean, now that you know you have moved into 0/0/0, okay, you can see this. So you are in 0/0/0 interface. Okay, then you can say give many values. So here I'll be giving the IP address. Okay, I told you we can give the IP address to the interfaces. Let me tell you how. We'll go to the interface and we'll type the command like this, IP address. Suppose I'm giving the IP 10.0.0.1. Okay, then suppose I'm giving the IP like this, 10.0.0.1/24. Then I'll be giving the IP like this. I'll go to the interface and I'll mention the command IP address, then the IP address I'll give, then instead of this prefix length I'll be giving the subnet mask. So what is the subnet mask, guys, for /24? For /24, what is the subnet mask? 255.255.255.0. Very good. Okay, so now, so here, sorry, we'll mention 255.255.255.0. Okay, now again let me exit it. Okay, again let me exit. Then let me show IP interface brief. Okay, now you can see gigabit Ethernet 0/0/0 has been assigned with an IP 10.0.0.1. Clear? Okay, but still the admin, so the status is down, I mean the status is administratively down and the protocol is down. So that means it is still down. So shall we make it up? To make it up, what you will do is that you will go to the same interface, configure terminal, then you will mention the command. Again you will go to the same interface like this, gigabit Ethernet 0/0/0. Then you can give the command no shutdown. No shutdown. You can see now the interface gigabit Ethernet 0/0/0 has changed the status. Yes, guys. Okay, you guys are late.
Yes, sir.
What happened?
Our old students are it, sir.
Sorry?
Your old students.
Old school. You are in dispatch only, right? Okay. So now gigabit Ethernet 0/0/0 has changed to up. Okay, and listen, I'm not sure how much you will understand. Okay, so now again show IP interface brief. I want to view the details of this interface. It will not work here because this show command, as I've told you, it needs to be executed in which mode? Enable mode. Exactly. Yes, or the privilege execution mode. Very good. Okay, yes, privilege execution. So but still, again, every time to go to the privilege execution mode, again coming back to the interface, again going back to the privilege execution mode to check something, again coming back to the interface is very, say, again difficult. Right, so what I'll do is that I'll execute the command, but in front of that command I'll give a show. Sorry, I'll give a statement called do show IP interface brief. If I give this, so I can execute the privilege execution mode commands in any prompt if I give a do in front of it. Clear? So now you can see it has now changed to, but again up bar down. It is up bar down. Okay, again if I take it, do show say interfaces, do show interfaces, you can view this gigabit Ethernet 0/0 is up, but the line protocol is down and it is disabled because it is not connected here. We have not connected the router's interface to any device, so it is still down. So first thing is that you need to make sure it is connected. So shall we now do the connections? Okay, so to do the connections, so now let me again take the packet tracer. Okay, so now suppose that you got some machines here, some computers. Okay, these are two computers. Suppose this is our CCNA classroom. Okay, now to interconnect these computers, we will connect a switch. Okay, now so from say there's the lightning symbol, so you can use this lightning symbol to connect cable. Yes, the cables, or you can take the cable, the straight through cable. I suppose I have taught you say the DC device and the DT device, right? Okay, and then I might have taught you that say to connect the DT device, the computer is a DT device, to connect the DT device to a DC device you can use the straight through cable. Yes or no? Okay, now again the switch is a DC device. From DC to router is a DT, so switch to router you can connect it from through straight through. So again you will click onto this straight through here. Okay, if you can see it clearly, so let me expand it. See, you can you see it straight through? Okay, so now you will click onto the straight through and you will connect to any interface of the switch. Then you can connect to this gigabit Ethernet 0/0/0 of the router. Okay, now when you take the router here this time, you can see these are the syslog messages. You can see the line protocol on the interface gigabit Ethernet 0/0/0 has come up. That means it has changed to up state. So now again let me check it. Do show IP or do show interfaces or do show IP interface brief. When you check it, you can see gigabit Ethernet 0/0/0 it has changed to up bar up state. It has changed to up bar up state. Clear? So now that you have connected, now suppose you got multiple computers here, you got many computers here, and this is the Bangalore branch. This is your Bangalore branch here. Okay, now suppose say you got another, say I'm taking another router here, another router, and now this router, suppose you got another branch here, Delhi branch. So you got multiple computers here and you will connect all these computers to a switch and then from the switch to a router. So suppose this is the Delhi branch again. So let me connect it here. Say so I can take some computers. Okay, then I can take a switch, then consider we have a lot of PCs, but say to like simplify it, I'm just taking 2 PCs. Okay, now so let me connect it again, the lightning symbol again. Say you can click the straight through here, you can click any interface, fast Ethernet, and again any interface of a switch, because we are not now concerned about the switch. Okay, now suppose here I have connected to any interface of a switch and to the routers gigabit Ethernet 0/0/0. If you want to see, so gigabit Ethernet 0/0/0, I'm connecting it. Okay, now again, okay, the router to router connection. Now just give me a moment. Okay, so now you got 2 branches. So one is the Delhi branch, or suppose this is the Bangalore branch and this is the Delhi branch. Okay, now if you want to connect from Bangalore to Delhi, you can connect it. And now let me tell you, and this connection, so here Bangalore is in Karnataka and you might know it's like south of India. Okay, now the Delhi of course is in north part of India, so it is geographically say separated. So if you want to connect the places which are geographically separated, then you will say or you will ask the service provider's connection. You will ask service provider's connection. So the service provider is one who provides certain service. What service will he provide? He will provide the WAN service here. He'll provide the WAN service. WAN means wide area network. Wide area network. And this is a LAN connection, local area network. It is just two local connections that we have done. Now to connect two LANs or two local area network which are geographically at different places, you can utilize this WAN connection, wide area network, and you will have to approach the service provider for that. So if you have, say, you will have a lot of service providers. You might have heard of Airtel, right? You might have heard of, say, Vodafone. You have a lot of service providers. So you will go, or you will approach them, and you will tell Airtel like this. Say, I've got a Bangalore branch here at this location, and I've got a Delhi branch at this location. I want a connection. So they will give you the WAN connection. And most probably they are going to go for something called leased line connection. Leased line connection. Leased line means, say, they will lease us the connection. Okay, so they are gonna, what happens is that, say, they'll be laying a cable exclusively for us, or through that cable only we will be sending the data. So that will be secured. That will be a secured connection. Getting it? Everyone? It's just theory. Now I'll come back to those things. Now, so again, I'll come back to the configuration, a little more theory. Now what happens is that, so here, this is our office, Bangalore location. Okay, and from the Bangalore location, what happens is that, say, from this is the Bangalore office that we have, and from this router we will connect it to the service provider's device. We'll connect it to the service provider. Did I tell you about this one? No. Okay, so we'll connect it to the service provider's device, which is in our office. So in our office, what happens is that, say, we'll have all the devices, and separately we will have a separate cabin or a separate, say, a section for the service provider's device. There, those things will be logged so that nobody else will use it. Only the service providers are authorized to use it, or only the service providers are authorized to take care of that machine. Getting it? So in our office, we'll have a separate section for the service provider's device. Okay, and from here what happens is that from this device we'll connect it to, or they will connect, the service provider will connect to the service provider's office, which is called point of presence. Okay, so that means this is the Bangalore point of presence. Okay, it means the Bangalore service provider's office. Then they will have the connection till Delhi. We don't have to worry about those connections. So now we have reached Delhi, the point of presence in Delhi. Getting it? And from that connection, say, then you will connect it to the service provider's device in our Delhi office. Clear? So this is in our Delhi office, and then from the service provider's device you will connect it to our router. So this is the leased line connection, or the WAN connection, you can say. Clear? So now suppose that, say, and this connection from the router to the service provider's device. So for this one we will use something called serial cable. We'll use the serial cable for connection. Okay, you can use the serial cable, but nowadays they are going with some other cables as well. They'll support the gigabit and all, or some other types of interface also they'll use. So for now, just understand, you will use the serial connection. Okay, so from here to here you will be using the serial. Now let me just tell you about one more thing. Now suppose that, say, you now know in between you have lot of devices. Now that I'm just ignoring all those devices and I'm just drawing a zigzag line. If I draw a zigzag line means in between you got lot of devices, but I'm just ignoring everyone. Clear? Okay, so I'm ignoring everyone. So what I'm gonna do is I'm gonna, say, connect a serial cable here. So first thing you need to check is that whether you have the serial cable or not. Okay, so here I've already added the serial cable. If I zoom in, I have already added the serial interface I've added. Okay, to check whether the router has the serial interface, either you can look it physically, or you can take the command do show IP interface brief. Here you can see the serial interfaces are there. But if you do not have the serial interface, now let me tell you, here you will go to the router and you will turn off the router here. suppose I have already told you this just now, you will turn off the router. Okay, and you will see the serial interfaces here. So this is NIM2T. When you check here, NIM2T is a 2-port multi-synchronous serial NIM. So that means this is a serial interface. What you're gonna do is you're gonna drag and drop it. Okay, that means I've just added. Say physically, if you want to add, say in the real devices, when you want to add, you will have that card. Okay, one card will be there, serial interface card will be there. You will insert it into this one. To the empty slot, you will insert the serial interface. Okay, now again, so this is how you will do it. Now that you will turn on the device. Okay, now suppose you want to connect it. Okay, then you can say click on to this one, anyone. So you can click on to this sliding symbol, say serial DC or serial DT, it doesn't matter. Okay, so now let me click on to this one and then say connect it. I'll click here and I'll click serial 0 / any interface you can give, any serial interface. Okay, again you can connect to any serial interface over here. So I've connected it. Getting it? Any doubts in the connections? These are just the packet tracer things, that's all. You don't have to worry about these connections because this will be done by the say L1 administrators or L1 engineers, like that. Or it's not the engineers really, it's a technician that you say who will establish these physical layer connections. Okay, now again let me tell you. So this is the connection. Now that you got the Delhi branch, so here and now I told you for say suppose the Bangalore branch, here for gigabit Ethernet 0/0 I have given the IP 10.0.0.1/24. Suppose the Bangalore branch is having the network like this 10.0.0.0/24 network. This is the network that is used by the Bangalore branch. Okay, so now again let me give an IP address to these computers which belong to this network. So let me give, this is a network and these are the assignable IPs. You can have the assignable IPs 10.0.0.1 to 10.0.0.254. Okay, so now let me give an IP here, suppose to the computers. Let me give an IP for this computer. I'll be giving an IP 10.0.0.2/24 and here 10.0.0.3/24. To give the IP address in the packet tracer, just click on to this computer. Just click on to this computer. You can take the desktop tab, IP configuration, where you will give the IPv4 address here 10.0.0.2 and the subnet mask is 255.255.255.0 because it's /24. And again for this computer also we'll give an IP. Here it is 10.0.0.3 255.255.255.0. Okay, now suppose here again, just give me a moment. So let me just draw it here. So this is the same thing. So this is the switch and this is the computers. These are the computers. Now this is the serial connection and this is the router. This is the switch and these are the computers. Now here we are giving the IP range 10.0.0.0/24. Now here you have the connection gigabit Ethernet 0/0/0. Here also we are connected to gigabit Ethernet 0/0/0. Now this is, if I check it, the connection is like this, serial 0/1/0 and this is serial 0/1/1. Okay, so let me just draw it, serial 0/1/0 and this is serial 0/1/1. So this is R1 and this is R2. Now here we have given the IP 10.0.0.2/24 and here also 10.0.0.3/24. Okay, and here 10.0.0.1/24. Any doubts so far? Okay, now suppose say this is the Bangalore router. and this is the Delhi router, and in the Delhi router also you can give an IP address. You can give an IP address. So suppose I am giving an IP here to this network or this one. So this IP, let it be just giving one 30.0.0.0/24. So this is, let me give an IP 30.0.0.1/24, and this is 30.0.0.2/24, and this is 30.0.0.3/24. So again, let me take the computers. (30.0.0.2), 255.255.255.0, and again the next computer. (30.0.0.3), 255.255.255.0. Now, yes, given it. Now to this gigabit Ethernet 0/0, I'll be giving an IP. I told you that I'll be giving an IP, say 30.0.0.1. So I'll be going into that router. So for you guys to differentiate, let me change the host names here. Okay, here let me change the host name like this. Host name is Bangalore router. Okay, Bangalore router, do show IP interface brief. You can see, say I've already assigned an IP 10.0.0.1 and it is upstate. It is perfectly working. Okay, now I'll go to the Delhi router and I'm gonna assign the host name first. Okay, so I'll assign the host name like this. Host name Delhi. Okay, you know how to assign the Delhi host name. Now that I'll go to the gigabit Ethernet 0/0/0 where I'll assign the IP 30.0.0.1. So the command here, I've already told you the command. So I'll go to the config mode. We'll say mention the command like this: interface gigabit Ethernet 0/0/0. Okay, yes. If you want, you can turn it off. No issues. Okay. Now you will mention in the config mode interface gigabit Ethernet 0/0/0, and when you press enter, you can see you have moved into that interface where you will give the IP like this: IP address, and the IP address that we will give is 30.0.0.1/24. So say 30.0.0.1, then instead of the prefix length we'll give the subnet mask, which is 255.255.255.0. Then you need to make this interface up. It's a must that you need to make the interface up. So that's because it is by default it is admin down and down. If you want to use the interface, you will give the command no shutdown, and you can see the interface it has changed to up, and the line protocol has also changed to up. So if you check do show IP interface brief, you can see gig 0/0/0 is assigned with 30.0.0.1 and it is upstate. Clear? Now say in the interface you can configure more things, that is say optional things. If you want to configure the bandwidth, okay, so or if you want to configure the delay parameters, you can configure it. To configure the bandwidth, you will give the command like this: bandwidth, and by default I told you the bandwidth is 1 Gbps. If you want to give any other bandwidth, you can give something like this, 100 or 1000 or whatever, but it will be in the kbps. It will be in the kbps range. Okay, so that is like optional things and all. If you want to configure something called delay, you can configure it. If I configure so 10 as the delay, okay, and if I execute the command do show interfaces, okay, you can see the delay will be 100 microsecond, because if you give 1, that will be taking 10. If you give 10, that will be taken, or it will be taken as 100. That's why it is tens of microsecond. These are optional parameters. Okay, if you want, you can give it, but giving the IP address and configuring it with no shutdown is a must thing if you want to use the interface. Getting it? Okay. Now again, so you have assigned the IP address, the LAN IP address to both the routers. Here you have here you have assigned 10.0.0.1 and here you assign 30.0.0.1. Similarly, you can assign the serial interface also. Okay, so now let me give the IP here for the serial. Suppose it is 20.0.0.1/30. Here also let me give the IP 20.0.0.2/30. Shall we? Everyone getting it? or board?
Yes.
Board.
No.
Can't see the responses from several faces. It's okay. Yes. Now, there. Yeah, he's always smiling. Right. Okay. Whatever happens, he'll be smiling. Okay.
Sir, I have one question.
Yes, please. You can ask.
Sir, suppose like in Bangalore, so many companies are there.
Yes.
Okay, so everyone wants to connect to the Delhi branch only. But
Okay.
Delhi branch is the main branch.
Okay.
So some like what I am configuring the IP,
Mm.
the another branch they don't know.
Mm.
Suppose the IP addresses is matched, then
IP address will not match.
Huh?
IP address will not match. You will never give the same IP address, and you can't give it because again, your name is sorry, again I forgot. Subhadeep. Yes. Now suppose, let me just tell you. Okay, Subhadeep. Okay, suppose Subhadeep has 3 brothers. You got 3 brothers. So your mom and dad has named you Subhadeep. Right. For the rest 3 brothers, suppose these are younger brothers, will they name Subhadeep? No. They'll be naming some other names. Similarly, so when you have here, say you will not give the same IP address anywhere. You will have different IPs. Clear? Now, was that your question?
Yes.
Okay. You will never ever give the same IP address then. Okay. Now guys, shall we continue then? Okay.
But that only happens in the same network, right?
That happens in the same network.
Yeah, but if it's in Delhi, like probably it's communicating via NAT system. So
Did we discuss that?
no, I mean if it's in Delhi.
We'll come to those things. At that time, we'll address those ones. Okay. So we have just started. Okay. Yes. Now guys, yes. So we are now discussing about now so let me configure the serial interfaces here. The serial interface will be serial 0/1/0. So I'll go to the Bangalore router and I'll configure this serial 0/1/0 with the IP 20.0.0.1/30. So let me go to the Bangalore routers. We'll go to the config mode. We'll mention interface serial 0/1/0. You'll go to that specific serial 0/1/0 interface. Well, you'll give the IP. The IP address is, say, what is the IP again? I forgot. 20.0.0.1. Okay, so you will mention 20.0.0.1. Okay, then you will give the IP 255.255.255. So what is the subnet mask for /30? For /30, what is the subnet mask? 255 dot 255 dot 252. Even though you have taken a look at the notebook, you told the right answer. Okay, so it is 255.255.255.252. Okay, then you will give no shutdown command. Clear? But when you give it, you can see it as the interface has changed to down. Your configured is no shutdown, but the interface changed to down. Because here when you configure it, for router to router connection, when you configure, you will have to make both the interface up, then only it will become up. Okay, so now let me go to the Delhi branch and configure this IP. This is serial 0/1/1 here. Okay, so now I'll go to a Delhi branch, interface serial 0/1/1. I'll be in that interface and I'll mention something like this IP address. And what is the address here? 30.0.0. Sorry, it's not 30 dot, it's 20.0.0.2. Okay, yes, my mistake. So it is 20.0.0.2 255.255.255.252, and we'll give the command no shutdown also. And now you can see the interface has come up. Okay, now when you check it, do show IP interface brief. Yes, you can see the serial 0/1/1. It is configured with the IP 20.0.0.2 and it is up bar up state. Clear? So this is how you will configure the basic things. Okay, now again you can go and check in the Bangalore router also whether this interface has come up. Previously it has gone down. So now when you go and check it, you can see some messages has come. Say line protocol of serial 0/1/0 changed to up. So after configuring, you need to check it. Do show IP interface brief. You need to check it whether the interface are having the same IP and say whether the interfaces are up bar upstate. There are chances that when you configure, you'll forget to configure no shutdown. So you will have to check whether it is up bar upstate, and you will have to make sure that it is to these interfaces that you have done the connection. Sometimes you will be connecting to serial 0/1/1 and will be making the serial 0/1/0 as up. So make sure these are the right connections. Okay, these are the right connections, and you have done the configurations to the right interface also. Clear? Okay. Now that, let me tell you. So now what you did? Now you are connected, say this one. Okay, the Bangalore branch you are connected and given the IP. The Delhi branch also you are connected and given the IP. And say the connection, the Delhi to the Bangalore to Delhi branch also you are connected. Okay, now shall we check the connectivity? So of course, now that you have enrolled for CCNA, our ultimate aim is to check the connectivity between the machines, how the connections are going, or how, say, the packets are flowing. Right. So let me check the connectivity from this computer to this computer. So, or let me go to this computer here. Okay, this is 10.002. From this 10.002, I am trying to communicate to 10.003. And say, what I'm going to do is that I'll go to this computer and I'll execute a command called ping. I'll execute a command called ping. Ping 10.003. It's as if I am from this computer, I am telling hello 10.003. That's it. So some packets will be sent. Some packets will be sent, and let's see whether 10.003 is replying or not. Okay, so I'll go to this computer. Okay, now I'll take the command prompt and I'll type ping 10.003. You can see pinging 10.003 and reply from 10.003. So that means from this computer I'm having the connection to this computer. When I pinged it, I'm receiving back the reply from 10.003. When you check this command, or when you check this output, you can see reply from 10.003 and send 4 packets, received 4 packets. That means 0% loss. That means everything is a success. Clear? Now again, in the real time also, you will check the connectivity like this. Say this is my physical machine. In this physical machine, if I want to check the connectivity, so you will be checking Google like this, right? So to check the internet connectivity, what will be the usual thing? The usual thing is that you will go to the web browser. You will go to the web browser and you will type www.youtube.com or suppose google.com. You will take it. This is the usual thing that you do. If you are not getting, then some error message will be shown here. Right, say some error messages. Now, from now onwards, you will be checking the connectivity like this. You will take the command prompt here and then you can check like this, ping google.com. Ping google.com. So when you do this, you can see pinging google.com, and the google.com has an IP address 140.250.77.110. And you can see the reply from Google is available. So that means you got the connectivity to the Google. Clear? Okay, so this is how you will now test the connectivity. Okay, now, so again, from this computer, shall check the connectivity to the router also, to the same router. Now that we are in the Bangalore, say we have checked the connectivity from one computer to another Bangalore computer itself. Now we'll check the connectivity to the router, the Bangalore router, so which is 10.0.0.1. Shall we? Okay, so now we'll go to this computer and we'll execute the command ping 10.0.0.1. We'll see whether we are getting the reply. We are getting the reply from 10.0.0.1. Right, so reply from 10.0.0.1, send 4 packets, received 4 packets, lost 0. Okay, now again, now that we'll check the connectivity from the Delhi device, from the Bangalore computer to the Delhi computer. So now, so this is having the IP, I suppose it is 30.0.0.2. So shall we check it?
Yes, sir.
Okay, so again, so now from this computer I am checking, say ping 30.0.0.2. We'll see whether we are getting the reply or not. It's showing something, request timed out. Any idea why it is showing the request timeout?
It cannot reach.
It is?
It cannot reach out.
It is not reachable, or say you are not having the communication, or something is, say some issues are there. Any idea what the issue is?
Do not.
Of course. So I taught you in the OSI, I might have told you that, say if you want to communicate from one network to another network, you must do a process called routing, or routing is the process of, say, communicating from one network to another network. So that's what we are gonna do. So if you want to communicate from one network to another, we need to have routing. Clear? Now, so yes, we'll go with the routing, but now let me tell you what happened really. Okay, so before even telling you what happened, let me tell you one thing. The routers here, you got the Bangalore router and the Delhi router. Okay, so the routers here, the routers actually maintain a table. The routers will maintain a table, and that table is called a routing table. It's called routing table. So the Bangalore router has got two networks here, and here the Bangalore router is assigned with an IP 10.0.0.1/24 here and 20.0.0.1/30. So the routing table is the table. It's a routing table. So the routing table contains the router's known networks. Routers known networks. Which are the known networks of Bangalore router? The Bangalore router is configured with the IP 10.0.0.1. So which is in the network 10.0.0.0/24 network. The network address is 10.0.0.0/24. Now, so it is also configured with an IP 20.0.0.1/30, which belongs to the network 20.0.0.0/30. Okay, so these are the known networks of the Bangalore router. Why? Because it is directly connected. So the interface are assigned with the IP addresses, the respective IP addresses. See, so that means it is directly connected. Getting it? Everyone? Okay, so now let me show it to you. So you'll go to the Bangalore router, and to view the routing table of the to view the routing table of a router, the command is show IP route. Command is show IP route. Okay, if you execute this command, you can see show IP route, and this is the routing table. Okay, when you check it, say C, something C is there. So C says 10.0.0.0/24 is directly connected to gigabit Ethernet 0/0/0. Why it is directly connected? Because it is assigned with an IP 10.0.0.1. The gigabit Ethernet is assigned with an IP 10.0.0.1. Clear? Now the same thing, 20.0.0.0/30. It's C here. C here means directly connected. It's connected. So it is directly connected to serial 0/1/0. Why it is directly connected? Because it is having the IP 20.0.0.1 in its serial 0/1/0. Clear? So here, okay. Again, just give me a minute. Okay. Yes, so suppose this is the, just give me a minute. So now let me draw it. So this is the routing table of R1. So routing table of R1, it has two networks. Which are those network? 10.0.0.0/24 and 20.0.0.0/30. So both are directly connected, and the alphabet C can be seen, and 10.0.0.0 is directly connected via gigabit Ethernet 0/0/0, and here it is directly connected via serial 0/1/0. Clear? Now, can somebody let me know about the R2's routing table? So which all networks the R2 will have in its routing table, guys? 30 dot? Okay, just give me a minute. Yes, I'll draw it. Just give me a minute, guys, because I don't have enough space to draw. Let me make some space here. Suppose this is dot 3. It's, you can understand. Okay. So now suppose this is the table, routing table of the device, router. So yes, of course. So R2 or the Delhi router is configured with the IP 20.0.0.2. So which belongs to the network 20.0.0.0/30. Okay. Now, so it is directly connected and it is connected via serial 0/1/1. Now here also you have assigned with an IP the gig 0/0/0 is also assigned with an IP 30.0.0.1 which belongs to the network 30.0.0.0/24 and it is connected via say gigabit 0/0/0. It is directly connected. Okay, let me show it to you. We'll go to the Delhi router and we'll take show IP route. You can see it is directly 20.0.0.0/30. It is directly connected to serial 0/1/1 and say 30.0.0.0/24. It's also directly connected to gigabit 0/0/0. Okay, now let me come to the packet flow. Okay, now let me tell you what happened when I tried to ping or when I tried to establish the connection between this computer and this computer. So when I tried to ping from this 10.0.0.2 and 10.0.0.3, from 10.0.0.2 I tried to ping to 10.0.0.3. So again, say some data is there. That data will pass through the say the application header, then the presentation header, then the session header, then the transport header, then the network header, and the data link layer header and trailer will also get encapsulated. Now let me just tell you guys. So here ping, or when you ping, you are actually sending or actually utilizing a protocol called ICMP protocol. You are utilizing a protocol called ICMP protocol. ICMP means Internet Control Message Protocol. Internet Control Message Protocol. So the ICMP protocol structure will be like this. ICMP actually works in layer 3. It's a layer 3 protocol. So the structure will be like this. Now, so you got an ICMP header here. You got an ICMP header. Then you got a layer 3 header. You got a layer 3 header. This, let me tell you, this is actually the data. Okay, why? Say you might be wondering, you do not have the layer 7 header, layer 6 header and layer 5 headers. Yes or no? Okay, because here if it's an application layer protocol, then you will have the application header, then you will have the presentation header, then you have the session header. So the thing here to remember is that not all the protocols will be having the application header, say presentation header and the session header. Instead, if it is working in layer 3, it has to be passed only up to layer 3. It is not necessary, or it shouldn't be passed to any other upper layers. Getting it? So everyone getting the point? There. Okay. So now, so what happens is that the ICMP header will have, or the ICMP will have a layer 3 header and they will have a layer 2 header as well. Let me show it to you, then you will understand. Okay, let me take the Wireshark. Okay, suppose this is a wireless connection. Now that, say suppose I'm trying to ping to, or CMD ping again google.com. So I have pinged it, reply from the Google, I am receiving it. Now let me check let me stop it. Okay, and let me check ICMP. Okay, you can see the ICMP. Okay, this is the packet that I've sent from my computer to the Google. So when I take this, you can see this. Okay, so you can see Internet Control Message Protocol. This is the ICMP header. This is the ICMP header, and you have IP header, IP version 4 header. So that's the layer 3 header, and you have the Ethernet header, which is the layer 2 header. Okay, so this is the structure of ICMP packet, which is a layer 3 protocol, and you will have this structure here. Okay, now so here when you take it, now let me come here. So come back to the process here. So when you ping from this computer to this computer, say you got the ICMP header, whatever is the ICMP header, you don't have to study now. So now you got the layer 3 header. So the layer 3 header consists of source IP and the destination IP. Now the source IP is 10.0.0.2. From 10.0.0.2, this machine we are pinging. So that means the source is 10.0.0.2. Clear? Now what is the destination IP? 10.0.0.3. Okay, now both are in same network. Both are in same network. So they will say, to get the MAC address, what they will do, say again, this is layer 2 header, and say they'll have the source MAC and they'll have the destination MAC. The source MAC will be the MAC address of this machine only, and the destination MAC will be unknown. So they will send the ARP, and say they will say the ARP request will be sent, and this guy will or send back the ARP reply. They will get the destination MAC, and then they will send the packet. This is very simple. Yes or no? Everyone getting it? Okay. Now there. Yeah. Subhadip. Yes. Now. Smile has gone. Okay. Yes. Now. Abhi also, right? Okay. Now, yes. Now, let me again tell you what happened when you try to communicate from here to here, to the router. The same thing happened. So the ICMP, that means you got the ICMP header. Now, you got the layer 3 header. And the layer 3 header, it says the source IP is this IP, the PC0's IP, which is 10.0.0.2, and the destination IP, which is 10.0.0. Sorry, yeah, the destination IP is 10.0.0.1 because it's a router's interface that I'm pinging. Okay, so if you do not know, so in the layer 2 header, what happens is that when they go for the source MAC, the source MAC is known, and the destination MAC they will find out by sending an ARP. Okay, and they will receive back, and then they will send the packets. Clear? Now, let me tell you what happened when this computer tried to ping to this computer. Shall we? Okay, in that case, again the same thing, ICMP header, then layer 3 header. Now the layer 3 header says the source IP and the destination IP. Source IP is 10.0.0.2, this computer's IP, and the destination IP is 30.0.0.2. Now here when it goes to the layer 2, now they'll check whether both are in same network or not. Now both are in different network. Both are in different network. If both are in different network, this computer really doesn't know it's in different network, then how to send it? That's what the question. Okay, suppose you are in, say you have just come to Bangalore, okay, and say you do not know the places. You want to go to a park. Okay, how will you go? You really don't know the place. Or suppose again, let me just tell you, this is your house, okay, and this is your plot, and this is your house. So to go inside your house, you know how to go. But to go outside your house, you will first have to know where your gate is. You will first have to know where your gate. So then through the gate only you can go. The same thing applies here. When you want to communicate to the different network, these computers should be assigned with something called gateway address. It should be assigned with something called gateway address, so that through the gate they can send the packets, and through the gate they can say send the packets to the outside world or to the other network. So now the gateway for these computers, yes, will be the router's IP here. Getting it? So it is via that router's IP, or it is via that router's interface you are sending the packets to the outside world, whether it is 30 dot network or whether it's 40 dot network, whether it's 50 dot network, whichever network it is. Right? Because I told you to communicate to different network, you have the router. So through the router's interface only you will be sending the packets to the other network. So the gateway address will be the router's interface address. What is the router's interface here? This IP is 10.0.0.1. Okay, so let me just go to this computer here. We'll have, you can see there is something called okay, so something called default gateway. Okay, the gateway address will be the IP address of the router's interface, which is 10.0.0.1. Again, let me go to the next computer. Again to this computer, and let me again give the gateway. The default gateway is 10.0.0.1. Similarly, let me ask you one more question. What will be the gateway for the computers in these LAN?
38.0.0.1.
Yes, the IP address of this Delhi router. So which is 30.0.0.1. So we'll go to this computer and we'll give the gateway address as 30.0.0.1. Here also we'll give the gateway address as 30.0.0.1. Okay, so now again let me go to those computers here and give the gateway address 30.0.0.1. Okay, now the next one. .0.0.1. Now guys, now let us try to ping. Now the problem is solved. Say, I suppose that I told you that if at all the computer wants to send something to this computer. Okay, now what happens? Say they will generate a packet. So this is the ICMP header. Now this is the layer 3 header. And the layer 3 header says the source IP, it is 10.0.0.1. The source IP, this machine's IP, which is 10.0.0.2. And the destination IP, it is 30.0.0.2, this machine's IP. Now, when it goes to the data link layer 2, what happens is that they will send the ARP. Now, let me just tell you a small thing here. Okay, so you know, or now the computer know, to communicate to different network, you will first need to send a packet to the gateway. To communicate to different network, you need to send the packet to the gateway. So in the layer 2 header, what happens is that you will have the source MAC and you will have the destination MAC. The source MAC will be the MAC address of PC0 and the destination MAC is the MAC address of this router's interface. Then only it will be given to the router. Getting it? Do you have a doubt in that? Okay, so what happens is that, so the destination MAC will be the router's MAC and the router will reply with the ARP. Okay, so now say what happens is that it will be forwarded, the packet will be now forwarded to the router. Okay, now getting it everyone, or do you want me to explain it one more time? Yes or no? Explain one more time. Okay, no issues. Now let me just tell you. Okay, so here the packet, okay, what happens is that the source IP and the destination IP, here you got it. Now suppose, again let me just tell you with an example here. So we have, suppose Abit is here, Abit, okay, and we have, suppose here we got Samarth. Yes, Samarth. Okay, and again I forgot you guys' name. Guys, come here regularly or else I'll forget your face as well as your name. Okay, now what was your name?
Shiva.
Shiva. Yes, Shiva. And Hemant. Yes, Hemant. Of course Joel. Yes, and Shubhadeep. Shubhadeep. Okay, and Sangeeta and Vishwanath, right? Now let me tell you. So Abid wants to send something to Vishwanath. So now the packet will be having from address. What will be the from address? Abid. From Abid. Okay. To Vishwanath. Okay. Now Abid cannot directly send it to Vishwanath. Right. So what happens? Abid will send it. So he will tell from Abid. Okay. Now Abid will be sending it to first Samarth. Okay. To Samarth. Okay. So Abid will first send it to Samarth. So the outer one, so here you can consider it as to layer 2 header, and here you can consider it as the layer 3 header. Okay, so outer packet or the layer 2 header says, say the packet should be first sent to say Samarth, and Samarth will get it and Samarth will read it. Okay, Abid has sent something to me. Then he will open it and he'll read it, and he'll understand it is actually Abid wants to send something to Vishwanath, not to me. So what he will do? He will again say cover it with a paper. Cover, say suppose it's a packet. He'll cover it with a paper. And this time he will be telling this is from say Samarth to Shiva. Getting it? Now, then Shiva will receive it. Shiva will receive it and will check it. Okay, when he checks it, let me tell you, so he'll check the outer packet or the outer cover. It says from Samarth to Shiva. So Shiva will accept it. Then we'll open it. When he opens it, he'll find it is the message from Abid to Vishwanath. So he just needs to pass it. So what he will do? Again, he will put it with a paper, or will cover it with, say, he'll remove the old paper, he'll put a new paper. Then he will say at that time, what he says is the say outer packet will be having the from address as Shiva and the to address to Hemant. So this inner packet remains the same. So actually the message is sent from Abid to Vishwanath. That one, it will remain the same. But the outer packet, it keeps on varying. Right. Then say when Hemant receives it, the same thing. Hemant will read, okay, from Shiva to Hemant. So it is for me. He'll say open it and he'll read. At that time he'll understand, okay, it is not for me. It is from Abid to Vishwanath. So what he will do? Again he'll cover it with a paper. Then he will send it to Joel. So this time Joel will also. So this time say the outer packet will have to say Joel from Hemant. Then Joel will accept it. Then again Joel will do the same. Then we'll understand Abid needs to send something to Vishwanath. Then again he will also cover it with something. The Shubhadeep will also do the same, and Sangeeta will also do the same, and finally it will reach Vishwanath. So when it reaches Vishwanath, the outer packet, say the inner packet remains the same. It will be from Abid to Vishwanath. Getting it? Now the outer one, it says from Sangeeta to Vishwanath. Getting it? So then Vishwanath will say open it. When he opens it, he'll understand that okay, it is actually the message from Abid. Say Sangeeta has just passed it to me. That's it. Getting it now?
Yes, sir.
Everyone?
Yes.
So what happens is that, say this packet here, where is it? So yes, now. So this packet remains the same. This is the packet. Okay, this packet remains the same. Now, so this machine is now passing it to the router first. So the outer packet will be having, so this, say the layer 2 header will be having the source MAC address as the PC2's MAC address, or this PC0's MAC address. And the 2 address will be the router's MAC address, the gig 0/0/0's MAC address. Then what the router will do is that, say this is router's gig 0/0/0 MAC. The router will receive it. It will receive it via the layer 1. It will receive it via layer 1. Then it will pass it to layer 2. And in the layer 2, that it will check, the router will check the destination MAC, whether it is really for him or not. Then he will understand the destination MAC is his own MAC address. Then he understands that, okay, it is sent for him. he'll say pass it in so he will accept it in layer 2, pass it to layer 3. So it passes to layer 3 and the router will be checking the destination IP. The router will be checking the destination IP. Yes, I know it is complicated, guys. Okay, usually what is that? Say I really do not explain it here. Okay, this thing usually I'll explain it later only. Now that I explained it now, I suppose you are getting it, right? You're not getting confused, is it? Everyone? Okay, now so here the router will now check the destination IP, which is 30.network 30.0.0.2. Now what he will do is that he will, so now the packet says, or the destination IP says, the destination IP is 30.0.0.2, and now he will check the routing table. He'll check whether he knows any route to 30.network or whether he has a route to the 30.network. So in the routing table of R1, do we have the 30.network? No, it is not there yet. So what he will say that the router will send back some message to the computer. I do not know this IP. The IP is unreachable for me. Clear? So now let me show it to you. So now I'll go to this computer and I will ping to 30.0.0.2. You can see the reply frame 10.0.0.1. 10.0.0.1. Who is the 10.0.0.1, guys? The router. Yes, here 10.0.0.1 here means is the router's interface, R1's interface, and the router is replying back like this: I do not know this IP. Okay, that means he doesn't know the 30.network. Clear? Let me take the message here. Reply from 10.0.0.1, destination host is unreachable. I do not know this host, or the host is unreachable. This network is unreachable. Clear? Now what you need to do is that now you need to mention in the routers, you need to mention how to go to the 30.network. How to go to 30.network. So we will mention in router, we will mention the unknown network. To the router we will mention unknown network. Okay, so the unknown network here is 30.0.0.0/24. So this process of mentioning the unknown network to the router is also called routing. Okay, or specifying the unknown network to the router, that is the routing. Now you can specify it in two ways, or the routing is of two types. Say, let me tell you, the first is called static routing. The first is called static routing, and the second is called dynamic routing. Static routing means we will mention the unknown network manually. We will mention the unknown network manually. That means ourselves, the network administrator will mention, even I am the, if I tell I am the network administrator, I'll tell, hey router 1, we got a 30.network. To go to 30.network, this is the path you need to take. This is the path you need to take.
So in PC 1.0.0.2, we mentioned the default gateway as 10.0.0.1. That is also part of static. Is that a
No, that is not routing. The routing is just now only the routing is starting. Okay.
We mentioned that we are manually mentioning the default gateway.
Yes, manually mention. We'll say everywhere we'll mention the default gateway manually. Okay, that is not part of the routing. That was just introduction to the routing. I was just talking about the packet flow there. Okay, now only the routing starts. Okay, right. Okay, now so here, now that we'll go with the routing, and routing you can do using two ways. The first is static routing and the other is dynamic routing. In static routing, we will manually mention the router like this. We'll mention in R1 like this: hey router R1, you got 30.network, and to send any packet to 30.network, you can send it via this path. Clear? Now, so you can mention it manually, and in router 2 also we'll mention. In router 2 does not know the 10.network. So we have to mention the 10.network in router 2 also. 10.0.0.0 network. Here R2, we got another unknown network which is 10.network. To send the packet to 10.network, you can send it via this path. Clear? Okay. Now that is static routing. That's called static routing. Now you got dynamic routing. Okay, dynamic routing means, let me just tell you an example. Say, yes guys? It's not dynamic, let me tell you. Okay, that means R1 knows about the 10 dot network, R2 knows about the 30 dot network. They will share mutually. Getting it? Suppose, say, we got Abit here. Abit. And we got Samarth here. Okay, so Abit, say he has a pen. Okay, Samarth doesn't have a pen. So, Amit will give pen to Samarth. Right? Mutually sharing their own things. That's it. So again, Samarth, suppose Samarth, say Amit doesn't have a book. Samarth has book. So what will Samarth do? He'll give book to Amit. So mutually sharing their own things. Or see here, that's the same thing. Here, R1 or mutually sharing the known routes. R1 knows about 10 dot network. So they will share the 10 dot network to R2. And R2 knows about 30 dot network. They'll share the 30 dot network to R1. Clear? So they'll mutually share the known networks. That is called dynamic routing. That's called dynamic routing. And dynamic routing is done with the help of certain protocols, and that protocol is called a routing protocol. That protocol is called routing protocol. Clear guys? Okay. Need a break?
Yes, sir.
Okay. You should ask me. Okay. I was so busy in explaining that even I forgot. Okay. So afterwards we'll continue. We'll get back at 6:56 p.m. I suppose that might be enough, right? Yes, guys. So now guys, again, so now, so where were we? Yes, so I told you that we'll be giving or we'll be mentioning the unknown network to the routers. Now if you want AC, you can put it.
I guess, sir.
Okay, you can just turn on the fan, that's enough. Yes, that's enough. So now, so here you can see we will mention the unknown network to the router. Okay, so now again I was telling you
Sir, it's dynamically that only select na, sir.
dynamically, say, let me tell you. Okay,
Yes,
you will understand once we study the dynamic, you will understand what really dynamic is. Okay, so routing, now just understand, say a routing is of two types, static and dynamic. Okay, static and dynamic. Okay, and static means we will manually mention it. Manually mention. Now guys, if at all you are feeling not comfortable, say you can swap the seats. Okay, do you not need the AC? You're having any issues with it? I mean, if you are not comfortable, I mean, I was feeling hot, that's why. So can you guys swap the changes, I mean swap the seats guys, because like I feel like they don't want the AC.
They don't want AC.
You're having some issues or something, because like one of my student in my morning batch, or I don't remember which
The
batch,
screen is not working.
string is not working.
You want AC or no?
Yeah, I want.
Want AC?
Yes.
Okay, then let me. I thought like previously I saw her like keeping her hand like this and all. I thought she might have some sinus or something. No. Okay.
I think it's Zendex.
Okay, no worries. Okay, so now guys, if you want you can just open it, that would be okay. It's feeling too hot.
It's on now. It will.
Okay, so now guys, again coming back, so routing, whatever, let me. So now routing, say I told you you got two types of routing, static and dynamic. In static we will manually mention it, okay, and in dynamic, say dynamic they'll use certain protocols called routing protocols, and they will mutually share it. We just need to configure the protocols. So these things, say the sharing the routes, they will do it mutually. Okay, that means they will do it automatically. That is dynamic. Okay, so you are not dynamically mentioning the routes and all, they will do it automatically. You just have to mention the protocols. Now the routing protocols, it is of two types. Okay, so the first type of routing protocol is called interior routing protocol. Interior routing protocol, and the next one is called exterior routing protocol. Interior routing protocol and exterior routing protocol. Okay, interior routing protocols, you have many protocols. The first one is called RIP, routing information protocol. Routing information protocol. The next one is OSPF, open shortest path first. And the third one is EAGRP. Enhanced Interior Gateway Routing Protocol. Still feeling hot. Okay. Okay, now I suppose it's okay. Right. Okay. So EAGRP, Enhanced Interior Gateway Routing Protocol. Okay. Now you got exterior routing protocol. I suppose you are writing, right? Okay. Now exterior routing protocol, you only got a single protocol which is called BGP, Border Gateway Protocol. Border Gateway Protocol. Now we will be studying the static routing, the manual one. Static routing we will study, and OSPF configuration you will study. Okay, RIP and EAGRP will just go with the theory portion. You do not have the RIP in your entire syllabus, and EAGRP is there from the CCNP level, and of course BGP is also there in the CCNP level onwards. Okay, so we'll be studying the static, the manual one, and the OSPF, open shortest path, first. Okay guys, yes. Now let me tell you one more thing. So routing protocols, you have it. With the help of these routing protocols, what are you sharing?
Book pen.
God. Okay, so now guys, come back. Yes, so you are sharing the networks or IPv4 routes or IPv6 routes. Okay, so these IPv4 or IPv6 routes, so or whatever you are sharing, that is called routable protocol. Routable protocol. So with the routing protocol, you are sharing something. What is it that you are sharing? You are sharing routable protocols, and the example of the routable protocols are IPv4 and IPv6 addresses. Clear? So in the interviews, there are chances that they will ask what is routable protocol and what is the difference between routable protocol and routing protocols. Clear? Okay. Now let me tell you, or let me just tell you how you can do the routing manually. Static routing. So you can write the heading static routing. Static routing. Okay. Now, so here, first of all, static routing, you know, I told you the unknown networks will be mentioned to the router manually. So now, just give me a, sorry. So which are the unknown networks, guys? For R1, the unknown network is, which is the network? 30 dot. Okay, so 30 dot. So let me write it with a different link. Say here 30 dot 0 dot 0 dot 0 slash 24. Okay, now you will mention it. Say 30 dot network is connected to serial 0 slash 1 slash 0. You can send it via serial 0 slash 1 slash 0. And you will mention it statically. That means you can see an alphabet S. When we do it, I'll show it to you. Okay, so now the same thing will be mentioned here for R2, which is the unknown network for R2. 10 dot network is unknown. Everyone getting it? Okay, unknown means he doesn't have it in the routing table. Okay, so he doesn't know about the 10 dot network, so we'll mention it statically. You will mention it statically. So 10 dot 0 dot 0 dot 0 slash 24 connected via its interface serial 0 slash 1 slash 1. So what happens is that when this computer, so now let me just draw it here, just a moment. So when this computer 10.0.0.2 is sending a packet, so this packet will have the source IP, which is 10.0.0.2, and the destination IP, it is 30.0.0.1. It's yes, 30.0.0.2 here. Okay, 30.0.0.2. Okay, now it will go to the layer 2, right? The layer 2, they will have the source MAC address and they will have the destination MAC address, and the source MAC address will be the MAC address of this computer, and the destination MAC address will be the MAC address of this gig 0/0/0. Okay, now what happens is that the packet will be sent to the router 1. Now the router 1, it will accept it in layer 2 and will check the packet, and the destination IP is 30.0.0.2. Now he'll check the routing table. He'll check whether he knows this route in the routing table or not. Yes, of course he has the route in the routing table. So he knows how to send the packet to 30 dot network. To send the packet, you need to send it via serial 0/1/0. Then what happens is that the packet will be sent via this interface. Getting it? Yes. Now the packet will be received at R2. The R2 will be checking the same. He will be checking the destination IP. The destination IP will be 30.0.0.2, and he will check whether the 30 dot network is present in its routing table, whether it's present or not. It is present. It is directly connected. It is present and it is connected via gig 0/0/0. Then the packet will be sent via the gig 0/0/0. Clear? Then this computer will receive it. Clear? Now it's not yet complete. When you send something from this computer to this, you will have to receive the reply. So when the reply is generated, so the reply will be generated from 30.00 to this computer to 10.002. So that packet will be having the source IP, which is 30.002 and it is 2. Okay, and the destination IP will be 10.002. Okay, both are in different network, so the packet will be sent to the gateway, that means the Delhi router. The Delhi router, what it will check? Yes? Okay. Yes, so the Delhi router, what it will check that? Say whether it knows about the destination IP or not, whether the 10 dot network is present in the routing table or not. So it is present in the routing table, so it needs to be sent via serial 0/1/0. So the packet will be, sorry, it is serial 0/1/1 here. Okay, it's my mistake, it's serial 0/1/1. So the packet will be sent via serial 0/1/1 and the packet will be received at R1, and the R1 will again check the destination IP, will check the packet. The destination is 10 dot network. It knows the 10 dot network where it is sitting. It is sitting in gig 0/0/0 and the packet will be sent via gig 0/0/0. Thereby the computer will receive the reply. Clear, guys?
Yes, sir.
So this is the process that happens when you do the routing. And now let me tell you how to do the routing. So the static routing, so here just now only I told we will do, or we will give the unknown network to R1. For R1 we will give 30 dot network. For R2 we will give 10 dot network. So the command syntax is like this. We will go to R1. Where is R1? Go to R1. The command syntax, we will go to the config mode. Okay, and we will mention it like this. The command is IP root. Okay, then the unknown network address for the Bangalore network, which is the unknown network? 30 dot network is the unknown. This is the unknown. So you will mention the unknown network like this: 30.0.0.0. Then the network, subnet mask is 255.255.255.0 because it's /24. Okay, then you will mention the exit interface via serial 0/1/0. Right, so you will mention the exit interface through which interface it is sent. So serial 0/1/0. Clear? So this is a warning. You don't need to check this one. It's fine. It's not an error. It's just a warning here. Okay, so now IP root 30.0.0.0, then the subnet mask, then the say this value, the exit interface. This interface is called exit interface. Clear? Okay, now almost done, guys. No worries here. At last we will mention the R2. In R2 we will mention the unknown network like this. So the 10 dot network will go to R2 here. Where is it? Yes, we'll mention the command like this: IP root. Yes, then 30.0.0.0, then /24. So that means 255.255.255.0. Then the exit interface, here it is, instead of 0.1/1. Okay, this serial 0/1/1. So here we'll mention the exit interface serial 0/1/1. Okay, that's also warning, no issues. Okay, so now let us check the routing table. So if you go to the routing table of Bangalore router, the command is do show IP root is the command to view the routing table. When you check it, you can see there is a 30 dot network mentioned, 30.0.0.0/24 connected via serial 0/1/0. Now the same thing, when you go to this router, and again if you execute do show IP root, then you can see this is 10.0.0.0/24 is connected via serial 0/1/1. Okay, now shall we send the packet? Okay, now if you send it, so we are sending it from, say, this computer. So previously when you send it, the router has told I do not know the network. Now he can't tell like that because now he knows the network. So now when you send the packet 30.002, let's see what happens. Yes, you are receiving the reply from 30.002. So receiving the reply, so here you can see, so pinging 30.002, you are receiving the reply from 30.002. Send 4 packets, received 4 packets. Clear? Yes or no?
Yes,
Yes,
sir.
Okay. Now again, so now this time the communication is proper. And to check the through which path it is going, you have a command called trace RT. The command is trace RT. Trace RT, say 30.0.0.2. Then you can see the path. It is first going to 10.0.0.1, then 20.0.0.2, then 30.0.0.2. So 10.0.0.1 here, 10.0.0.1 this router's interface, then 20.0.0.2 this router's interface, and finally to the computer 30.0.0.2. So the packet flow is like this. Any doubt? Yes or no? No. Okay. So this is the routing.
So router to router we can check.
Yeah.
Router to router also you can check. Yes. Router to router also, if you want to check the connectivity, you will go to the privilege execution mode. Okay. So now if you want to check the connectivity, suppose you want to ping from R1 router to this computer 30.0.0.2. Okay. So then what you will do is that you will go to router R1. Okay. I mean this Bangalore router. Then you will go to the privilege execution mode where you will mention the command like this, ping, then the IP address is 30.0.0.2. You can see, say 5 packets are sending 5 packets and the success rate is 100%, 5 of 5. That means this is success. You have the communication from this router to 30.0.0.2. Clear? And of course you know the packet flow. So when this router generates the packet, say the router here, when this router is sending the packet to 30.0.0.2, the packet will be having the source IP as, what will be the source IP? This is the source IP 20.0.0.1. Because when they check the routing table, they'll understand the 30 to contact the 30 dot network. The exit interface is serial 0/1/0, and what is the IP address of serial 0/1/0? It is 20.0.0.1. So the source IP will be 20.0.0.1 and the destination IP will be 30.0.0.2, and the same process. So it will check the routing table, it will be forwarding via this interface, and R2 receives it. He will check the routing table 30 dot, it's directly connected, it will send via gig 0/0/0, and the computer will receive it, and the reply will be generated and the process happens. Clear? Any doubt? Anyone? Anybody?
Can you explain one more time, sir, last?
Simple thing. Who will explain it? Who has the confidence to explain the process that I just now told? Yes, Siva. Yes, Hemant. Hemant. Yes, Hemant. You will tell the answer. And if at all you are not telling the answer, I know what to do. Yes, Hemant. You will tell the answer. Yes. I don't know. Just explain to you, right? What happened? Just told you the working of this one from the router to the computer. What happened?
Routing.
Yes, the packet flow. I need the packet flow. Yes. You can start. From R1 to the computer. From this router 1 to this computer. Yes.
When you ping 30.0.0.2,
Mm.
it will go through default gateway.
Default gateway.
Routing.
Routing. Did we mention any default gateway to the R1?
No, sir.
Then?
We already
You already?
set,
Already?
set
Said what?
gateway.
Gateway. So what is a gateway here?
R1, sir.
R1. R1 itself is a gateway for R1.
Yes.
I'm not getting it what you are telling. Yes, Shiva, you can tell the answer.
R1 to R2,
R1 to R2.
then to computer, sir.
Yes, you can tell the whole process here. You can tell what happens here when you ping from R1 from the packet level. I need the packet level answer.
We have a
You have?
20.0.1
How did the router get 20.0.0.1? And what is that?
serial.
Serial.
No, sir.
Then? Yes. Yes, guys. Who will tell the answer? Who has the confidence to tell the answer? Here? No. Yes, Shubhadeep.
So first,
Hmm.
we settled the that default gateway. Okay.
The default gateway.
Before that's the process it is.
Do we have a default gateway mentioned in R1?
No.
Then?
No, we just search that what is the unknown IP to communicate the router to the system.
Router to the system, the unknown IP.
Yeah.
Okay, I suppose you are referring to. So I just want the contents in the packet.
Yes.
What is the source IP and what is the destination IP?
The source is 20.0.0.
0 to
20.0.0.1.
1.
How did he get the source IP as 20.0.0.1?
Routing. That's a known. First routing table. That is a serial port.
Routing table, of course. Now let me tell you. So if at all the router wants to generate it, to generate the packet to, so the destination IP, say it is 30.0.0.2. It's 2 to this computer that you are pinging. Okay, if you want to ping to that computer, okay, so the destination IP is known. We have mentioned the destination IP. Now they'll check the routing. So this is the L3 header. In the L3 header, you got the destination IP which is 30.0.0.2. Now, so they will check the routing table how they need to say go to 30.network. So now in the routing table to go to 30.network, it is written via serial 0/1/0. You can communicate to 30.network. Then they know via serial 0/1/0 he can communicate. So what is the IP address of serial 0/1/0? 20.0.0.1. That means to contact, say that's 30.network, he can contact via 20.0.0.1. So that will be the source IP. That's how they will find out the source IP. Getting it? If at all they want to communicate to 10.0.0.2, what will be the source IP then? 10.0.0.1 will be the source IP. Getting it? Everyone? Okay. So now, again, so here, then they have filled the layer 3 header. Then this packet will be sent to the router 2. And the router 2, what it will do is that he will check the destination IP, 30.0.0.2 is the destination, and he'll check it in the routing table. How to send the packet to the 30.network. Okay, now he will come to know that the 30.network is connected via gig 0/0/0 from the routing table. Then he will send the packet via gig 0/0/0. Clear? And the packet reaches this computer. And the computer will reply back, say the computer will reply back. So 30.0.0.2 will reply back to this 20.0.0.1. Because say the source this 20.0.0.1. You are pinged from the source 20.0.0.1. So the reply will be generated to 20.0.0.1. Everyone getting it? There? Now the next time when I ask you the questions, I should need the answer. Okay? Yes. I'll allow fun and those things in the class, but you need to listen here. Okay? Now, so here you can see. So 20.0.0.1. So then both are in different network. This packet will be sent to the Delhi router. And the Delhi router, he will check the routing table, how he can send the packet to 20.network. So he will come to know from the routing table, it is connected to serial 0/1/1. Then the packet will be sent via serial 0/1/1, and this router R1 will receive it. And R1 will do the same process here. They will check the destination, say the destination IP. The destination IP is 20.0.0.1 and it is its own IP. So it will be accepted in layer 3 as well. Then will be passed to the say ICMP or whatever the respective say section is. It will be passed to that section. Clear? Any doubts? This is the process.
Bharat, I had a doubt.
Yes, please.
So the command is IP route destination IP subnet mask and egress interface, right?
Yes.
So the egress interface you mentioned as serial 0/1/0. So instead of that, can you just mention the IP address of the egress interface rather than
Of
the
course, you will
interface?
mention. You will mention and you will study that tomorrow. No worries. Okay, we'll study that tomorrow. Okay. Yes. Any other doubts? Yes or no? No. Okay. Then shall we wind up the class for today? Okay. Go home and do this topology today itself. Okay. Yes. So thank you guys. Just hold on a minute. Yes. Yes.
Sir, in the 10.0.02 from the first device to 30.0.0.2 we are sending data, sir,
Okay.
packets. The in this source IP is 10.0.0.2.
Okay.
Here also 2, sir. But in router, the router's 10.0.0.1 is the router's IP.
10.0.0.1 is the router's IP.
When sending sir from router 1 to why the it will source IP, it will take serial's IP.
Serial IP because in the routing table to contact, say, now let me tell you. Let me tell you just say with an example. Okay. Now, suppose to your right side, I suppose this is your left side, right?
This side.
Yes, that is your right side. Okay. So now, suppose this is the right side. To suppose Samarth right side, okay, we have Joel sitting. You're right, Joel. Okay, Abit. Okay, for you, Abit. So for me, it is Joel. Okay, so suppose Abit. And to your left side, say Joel is sitting. Okay. Now, so you know that Joel is sitting to your left side. So through which hand you will give him the cake? Suppose you got a cake. Through which hand you will give him the cake? Through the left hand or the right hand?
What's your left hand?
Left hand. Because say Joel is sitting to left side. So you will be giving him the cake via left hand. Hey Joel. Like this you will give. Okay. Now to Abid, say Abid is sitting right side to you. So you will give the cake using your right hand. The same thing here. Okay. So suppose you got the router. Okay. Router is connected to 30 dot network, 30.0.0/24 network. Via suppose it's serial interface. Okay. So when you want to send the packet to 30 dot, you are mentioned in the routing table to contact 30 dot network, you need to send via the serial.
Yes.
That is what that is mentioned in the routing table. So then the packet needs to be sent via the serial. Then they will check for the serial interface IP. What is the serial interface IP? 20.0.0.1. Now got it?
Yes.
Same thing. Okay. Yes. So then we shall wind up. So guys, give me a moment. So let me stop recording.